In this video, we'll discuss the similarity within area and volume of similar shapes. So say that we have a shape or solid that's similar. Then what we know is that the corresponding side lengths must have a proportional scale factor. If it's a shape, we know that the areas must be proportional based on the square of that scale factor. And if we're comparing the volumes of two similar solids, we know that the volume will be the scale factor cubed. So say that we have a scale factor of the side measures of two solids and we know that it's a 3:8 ratio. Then we want to know, well, what about the surface areas and the volumes? Well, the surface area is a type of area, so we know we square each of those terms to look at that ratio. So we'll be looking at the 3:8, each of those values squared. So 3 squared is 9 and 8 squared is 64. So the area ratio is 9:64. Whereas the volume ratio will be the cube of each of those. So we cube 3:8. That becomes 3 cubed and 8 cubed, so it's a 27:512 ratio between their volumes. Now, if we need to determine if there is similarity, we need to verify the scale factors of all the corresponding sides, make sure that they are equal, and then we need to make sure that the corresponding angles are congruent. So here's an example. Say that we have these two rectangular prisms and we want to know, are they similar? Well, knowing that they're rectangular prisms helps us to know that we're dealing with right angles at the corners, so we know the angles have to be congruent. Then we need to say, okay, what about the lengths? Well, we know that because it's a rectangular prism, we only need to know about the length, the width, and the height of each rectangular prism and compare them. So let's look at the scale factor for the lengths. Then let's look at the scale factor for the width and then the height. So the scale factor for the length is 9 feet to 3 feet. That's a 3:1 ratio. Now we look at the widths. The widths are 6 feet to 2 feet, which again is a 3:1 ratio. Finally, we look at the ratio of the heights. That's 15 feet to 5 feet, which is again 3:1. Since all three have the same scale factor, we know that the prisms must be similar. Now, if you need to solve for area or volume or some part of those, including the scale factor or missing side from two similar objects, we got two ways we can often do that. One, we can use the scale factor to calculate missing side lengths, and then we can find those missing sides and then use formulas to actually calculate the area or volume of the respective similar object. The other thing we can do is we can start with the scale factor and either convert the ratio of the areas of the volumes, or if we have the ratio of the area and volumes, we can convert that back to the scale factor. We can then use a proportion of the ratio to the other areas and volumes to help us find the missing objects. And we can solve then for the area of that missing volume based on that proportion. Often cross-multiplying and dividing is the most common way people think of this. All right, let's look at some examples of area and volume. So we have a rectangle with a length of 5 inches and a width of 3 inches. And we know a similar rectangle has a width of 6 inches. And we want to know what's the area of the similar rectangle. So let's first draw two rectangles. Let's label the smaller one with the 5 inches and the 3 inches. And here I've called this bottom side the length and this left side the width. So that means on my larger one, this left side, I'm going to label as my width of 6 inches. Now I can either figure out what is this missing side to calculate the area, or I can use the ratio of the areas. Let's first do it using the calculating that missing side. So we're going to call this x. And if I set up the ratios, I would be saying 3 to 6 equals 5 to x. I cross multiply, and then I'm going to divide both sides by that 3 inches and say that this missing side has to be 10 inches, which makes sense because it's a 2:1 ratio where 6 is double 3 and 10 is double 5. Now I can say, okay, let's calculate the area of this rectangle, which is length times width. That's 10 inches times 6 inches, which is 60 square inches. So that's the area of that larger rectangle. The other way I could do this is use the ratio of the areas. So let's first say, well, what's the area of the small rectangle? Well, this is 3 by 5, which would be 15 square inches. And then I have to think about, well, what is the scale factor? The scale factor, as we said earlier, was 3 to 6, which is a 1:2 ratio if we're going from small to big. And so if I'm looking at the ratio of the areas, I need to square that value. So 1/2 squared becomes 1/4. It's a 1:4 ratio of the areas. So I could set up a proportion of the small to the big with that ratio of areas. So here I know that it's 1:4, and then I'd say, well, the 1 was the smaller rectangle, so that's its area, and then x is the larger one. I cross multiply again and I get that x is 60 square inches. Same answer, just a different way of thinking about how to solve this problem. And it's good to have multiple methods because here's a problem where we have a 4-foot circular flower bed that's left unattended for a year. Now it's covered and the bed has doubled in size. And it's covering double the area that it did before. It will know how wide is the bed currently to the nearest tenth of a foot. So first, we don't necessarily have a formula. We could use circles to do this, but let's look at this from the idea of the areas to determine the scale factor. Because what we're told here is that the area has doubled. So when we think about it, we have the ratio of the areas. We can use that to go back to the scale factor. Because the ratio of the areas is the scale factor squared. So we know the ratio is a 2 to 1, and we know it's the scale factor squared. So if we want just the scale factor, we take the square root of both sides. And we're going to be left with the scale factor equaling the square root of 2 over 1, which is the square root of 2 over 1. Now I can then say, okay, well, what do I know about the sides? I know that my sides have gone from a 4-foot diameter, and I don't know what the new one is. So the 4-foot represents the smaller side where it started, that was the 1, and then the square root of 2 is the unknown length. So we cross multiply here, and we get 4 to the square root of 2 feet will equal the length of this new bed. And they do want it approximated, so we would take that, put it in our calculator, and round it to the 10th. But let's first double check these lengths. So we know that, as we said, this is a circle. So if we want to know the area of each of these flower beds before and after, well, we know it'd be pi r squared. So since this is a 4-foot diameter bed, I would use 2, and 2 squared would be 4 pi square feet. The new one would be half of this value, because this is the diameter, so that would be 2 to the square root of 2 squared, and that becomes 8 pi square feet. So it is double the area of the original bed. And if I want to change my value that I found for that new diameter, I just put my calculator and get about 5 7/10 feet wide. Now let's look at a similar volume with these two rectangular prisms, where one we know is 2 feet by 3 feet by 6 feet, and the other one we know the length is 8 feet and the height is 24 feet. And we know what's the volume of the similar pyramid, this larger pyramid. So again, we can do it one of two ways. We can use the scale factor and then calculate that missing side and then calculate our volume. So let's try that. So we know if we use corresponding sides, 24 to 6 will equal the width to 3. You also could have done 8 to 2 equals the width to 3 because it's all the same scale factor of 4 to 1. So I cross multiply here, and I would then divide by the 6 feet and get that this is that width is 12 feet. Now to calculate my volume, I know it's length times width times height for a rectangular prism. So 8 feet times 12 feet times 24 feet will give me 2,304 cubic feet. The other way is I can look at a ratio of the volumes. So I know, like I just said, that the scale factor is going to be a 4 to 1, but let's also understand what's the volume of that small prism. So I need this prism here, so that'd be 2 feet by 3 feet by 6 feet, which is 36 cubic feet. Now let's say we're going to take that scale factor. That's the length scale factor. We need the volume scale factor, so we're going to cube it, which is 1 to 64. Now I can set up my ratio of the volumes as a proportion and say that's 1 to 64 will equal the volume of the small one to the volume of my big one. Again, I cross multiply here, and I'm going to get that x equals 2,304 cubic feet.